Good morning, everyone. I hope you guys had a wonderful Thanksgiving. I know I did, even with the kind of odd year that we are having. But it is, of course, time to get back into the wonderful world of algebra. And what we're going to be doing today is kind of taking just a half step forward. What we're going to be doing is we are going to be solving equations that are not quite as neat as our previous equations, which is honestly a little bit fun because just like real life, math can get a little messy, and that's not necessarily bad. It just means that you face a few different challenges. So let's look at how to solve problems where x is not going to equal a whole number or a nice fraction. And really, this doesn't change our process. Let's take a for an example. Let's say I have 24x plus 43 is equal to 66. What I know is when I want to solve for x, what I want is to figure out what x value could I put into x in order to get 66 as an answer. And in order to do that, I have to solve for x, or get x by itself. So I'm going to drop this line to keep everything balanced like normal, and I'm going to go through the reverse order of operations and move all of my addition and subtraction to the other side, then my multiplication, division, and so on and so forth. So let's start by moving the 43 over by subtracting 43 from both sides. Well, that gives us 66 minus 43, which we know is 23. And of course, just watch negatives. That makes sense that it'd be smaller than 23, or smaller than 66, but still positive. And on the other side, I have 24x left, since the 43's cancel. Here, in order to get x by itself, I have to undo the multiplication done. So I'm going to divide, since division undoes multiplication, and I'll divide both sides by 24. Now here's where it's a little odd, because let's take my calculator for a second. If I do 23 divided by 24, I get an answer of 0.9583 repeating. So this would be 0.9583 approximately, right? And by the way, when we do approximately, we do these little squiggly equal sign. That means it's about that. Or you could say it's exactly equal to 23 over 24. Now, either of these answers would be considered correct. And we have seen answers like this before. The key thing that's going to change when you have a decimal answer is checking your answer is going to get, well, a little bit messy. So let's do that second step, because of course we always check our answers when there's any possibility of checking them. So in order to do that, I'm going to, excuse the jump there, write out my original problem and just see if the x I found, this, will fit in to the equation completely. So I want it to equal 66. Well, let's put in our decimal. We can also put in our fraction. So I'm going to start with the decimal. Let's do the 0.958. And I'm going to just take off the 3 and use 3 decimal places, which is fine. That's fine. Either the hundredths or the thousandths place is a fine rounding place. So when I type this into my calculator, I can do this step by step or just carefully watch my order of operations. I can do 24 times 0.958 plus 43. Now notice that the answer I get is 65.992. So when I've typed all of this in, I get an answer of 65.992, which is not the same as 66. This is not quite true. But keep in mind, this 0.958 is also not quite my x. It's really close to my x value, but I really need that 0.3 repeating, or that 3 repeating at the end in order for it to be exactly x. So that means that the answer I get here will not be exactly 66, but it will be close to 66. Now, how close is close enough? Generally, you want to be within a couple very small decimals away. So see how this is 65.992. If I even round it up to the tenths place here, it would bring this up to 66. So that's close enough. So you can also check this by using the fraction. And this is better because this should give you an exact answer. Now you have to be careful when you put fractions into your calculator that you're using parentheses around them, or it will not give you, most of the time, the correct answer. But if I do type this in very carefully and I do 24 times 23 over 24 in parentheses plus 43, I get an answer of exactly 66. Now this is why I'm a bit of a pain or pest sometimes, because I demand those perfect exact answers that are fractions. That's because they will give you the exactly right answer as opposed to the approximately right answer, and that can be handy sometimes. What I would like you guys to do is solve B on your separate sheet of paper. And I want you guys to also make sure that you check your answer. Do it with the decimal and check your answer with the fraction as well. That way you know for sure you got the right answer. Now let's say you've checked your answer a couple times and things are going wrong. I would like to point out that there is a negative in front of the 42, and that negative sometimes gets lost. So if your answer is not negative, check that you kept that negative around that 42. Now, if you've tried it a couple times and you haven't got it, here is how you work through that problem. Also double check that your answer is right. You should have either negative 59 over 42, which you can write as a mixed number as well, or you could have approximately negative 1.405. I would still like to see your check of these, even if that's not how the answer that you got. Run through, double check why it would have to be that, and show me that you've checked and confirmed that this is, or perhaps is not, the correct answer. For our next step, we're going to look at what about an actual equation with decimals. So we've had answers where x is a decimal, but we really haven't had equations where x or where values are decimals in there. So what we're going to have to do is we're going to have to solve these slightly messy ones. But don't forget that just because you have a decimal, it doesn't mean that your problem has actually changed that much. Decimals are numbers. 3.5 is a number just as surely as 1 and 2 are numbers. So treat them as if they're normal numbers, because they are. And solve for x like you would normally. Now here, notice that in this problem I have two x values, which can be a bit of a pain. So I'm going to want to get all of my x's combined on one side of the equation. So I'm going to have to move some x's over. And you can do this one of two ways. You can move your 3.5x over to the other side by subtracting 3.5x, and that will give you a negative on this side because 3.5x is bigger than 0.2, but it will get all the x's together in one go. Or you can move that 0.2 over by subtracting 0.2x from both sides, and remember, when you're doing this, line up your x's, right? You're going to be subtracting from like terms. And the nice thing about this is we are going to be left with positive numbers. 3.5x minus 0.2x is 3.3x. And of course I still have that 37.9 subtracted at the end. Now the reason why this sometimes throws people off is on the other side I'm going to end up with a 0 because I have nothing left, but nothing is a number and that number is 0. This is still kind of nice though because I don't have a negative on this side of the equation. And remember that 0 is a number just like any other number, so I can go ahead and solve just like normal. I'm going to be moving everything away from the x by adding 37.9 to both sides, which gives me a 3.3x is equal to 37.9, and divide by 3.3, remember it's just a normal number. And that will give me x is equal to, well, let's actually divide those. 37.9 divided by 3.3 is going to give me 11.48, where 48 is being repeated. Now, again, like normal, I would check my answer. So I want you guys to go ahead and do the check. Remember that this is a decimal answer. Perhaps you're going to have to do a little bit of rounding, or maybe you leave this as a fraction. Now it's a very ugly fraction. 37.9 over 3.3 is pretty stinking ugly, but it will function just like normal. It doesn't need to be pretty to be effective. All right, so what I want you guys to do then is show me your check for this problem and go ahead and try B as well. I'm going to show you the answer for that in a moment, but I want you to try it out on your own. And what you guys are going to do is you guys are going to submit on Classroom the problems that you guys did or the work that you did as the video went on. So I just need to see your work for your homework today. You don't have additional problems beyond that. All right, and here is that answer to the second one. Now remember, I'm going to need to see both the check for this one, and of course the two problems at the beginning for your assignment posted on Classroom. Let me show you that final one once more. I hope you guys have an excellent day. I will see you tomorrow.